Okay, so the last thing that we'll do here in this video is actually seed our database with some initial data. So the template provided a very useful seed data class here that you can see, and if we just open this up quickly, we can see that it contains a single method, ensure seed data here, and all it's going to do is again make use of Entity Framework using our application DB context, check to see whether or not we have any users. So in particular, it's going to check to see whether or not it has a user with the name Alice, and it's also going to check whether or not we have a user with the name Bob. And if we don't have such a user, then we're going to new up an application user entity model with the username Alice, and then what we're going to do is use this user manager service to create that user Alice with a password. In this case, pass123$. If something goes wrong in this process, then it's going to throw an exception with the stack trace out to the console. Otherwise, we're going to continue using this result object that we're working on here to add some user claims to this user. Again, throwing an exception if anything goes wrong, and then finally saying that this user Alice was created. If it so happens that we run ensure seed data and this Alice record already exists, then we will skip all of that and just write Alice already exists out to the console here. And likewise, we have just a very similar thing for creating a user Bob here. Okay, so now you may be wondering, well, where does this ensure seed data method get called? Well, it actually gets called in our program.cs method, which is the main entry point for this application. So you can see that the application takes string array args. We have a var seed here where we basically say, do any of the arguments contain this string /seed? And if they do, then args is equal to the args except seed, and so what that's doing is just redefining args without seed, but we have this boolean value of seed set to true now. So what we can do is if seed, ensure seed data gets called on our seed data class. By stripping seed from the args after we have set this bool, we can build the web host as if we hadn't supplied any arguments here, because build web host doesn't need any args passed to it. Essentially, we just want to set this bool here to check whether or not we want to seed data for our database. Again, if this /seed is provided, then we just return out of this main method and we don't run the host. So this provides us with a sort of ad hoc tool, if you will, for seeding data. So we can actually see that in action if we head back here. And we .NET run, which is the command to actually run our application. Again, the entry point of which is that class that we were just looking at here, this program class. And if we just /seed here, what's going to happen is we're going to enter that if statement where we have seed as part of our args, and you can see that our ensure seed database method got called because we can see that Alice was created and Bob was created. If we head back into our seed data class, we can see that what just happened here is that both Alice and Bob application users were created with these claims, and by calling this add claims async and create async for this user on the user manager, we essentially just created these asynchronous tasks to write inserts into our database, mapping these objects into SQL statements that were just run against our Postgres database. In fact, you'll see if we just head back into Postgres here, and I run a new select statement against our archdb.dev public ASP NET users. You can see that both Alice and Bob were just added to our users table. So you can see that they have their passwords hashed, they've got their usernames and some GUID for their IDs. Likewise, they have some claims, which if I just double click here in DataGrip, I can run a select statement on that table, and we can see the different claims that were defined in the ensure seed database method. Roles is still empty and login is empty. Okay, so one more thing that we can do here is write some code to programmatically initialize this database when our application starts. So we did all that manually after building out the startup class. We ran our migrations, and then we seeded the database with some of this initial identity user data. But we can also write a function that will initialize this database programmatically when our application starts. So let's take a look at that. If we head back into the code, what I'm going to do is get out of seed data and get out of program, and we're going to head down to the bottom of our startup class, and we're going to write an additional helper method here called initializeDBC. And we're going to pass in an iApplication Builder service here. This code, or code that's very similar to this, is also available in the quickstarts provided by IdentityServer 4, so I'll post a link to those in the description. But if you'd like to follow along here, it's not a very complex method, so we're just going to write it out by hand in this case. First of all, what I'm going to do is call migrate on the persisted grant DB context. So we'll go ahead and get a reference to our service scope, and we can do that with a using statement. And so this is from our application services. We can get a particular service by its type, which in this case is an iService scope factory, and we're going to create a scope for it. So all this is using, all that we're doing here is creating a scope in which to use a service for this particular period of time here within the using block. So within here, we have this service scope, so we can actually get any of the services that we might require to complete some action here. So on the service scope, we have a provider object, and we can get a required service of whatever type that we would like here. In this case, we're going to get our persisted grant DB context, and we can control or command period here to bring in IdentityServer4.entityFramework.dbContexts. And on the database object here, we can just call migrate. So what this is going to do is, for the database that we've defined for our persisted grant DB context, we are going to apply any outstanding migrations on it. So first of all, if none exist, then it's going to create the database, and then otherwise, if there are any outstanding migrations, it's going to go ahead and run those as well. We're not going to add any persisted grants to that table, but we can add some things to the configuration DB context. So we're going to store a reference to that in of our context. We'll use the same service scope here to get the required service for our configuration DB context this time. And now that we have a reference to that, we can call, again, database.migrate on this particular context. And I think it helps here to maybe call this the configDBContext, just so it's more clear which DB context we're talking about here. And if it makes it more clear, I can also just do like a persisted grant DB context is equal to this, and then we can call persisted grant DB context.database.migrate. That's all we're doing with the persisted grant DB context, is running any outstanding migrations and creating that database if it doesn't exist in the first place. Again, we're using the same database for persisted grants and configuration within IdentityServer, and so this is getting run first, and it's basically just going to create that database and create that single table. So I'll come down here and clean this up likewise. We have these as two separate events, again, because although we're using a single database, we could theoretically use two different databases for each of these contexts. And then we're going to write some if-else statements here to see whether or not we have any initial data in our database. So what I'm going to do is say, if within our context, if within our configDBContext, we don't have any clients defined, and if you don't see any, this is part of link, so we can bring in system.link into our usings. Then we want to add some clients, and our template actually provides us with a method in a config class here. If we take a look, you can see a few methods here within the config class. We have these static methods in this static class to basically create some new resources and create some new clients. And so this, again, is just sort of placeholder data that we could configure if we'd like. We have 3 clients that are brought in here with this, one called a client credentials client, an MVC client, and a SPA client. So let's go ahead and just use the scaffolded code here in our initializeDBContext method here. So if we don't see any clients, then for each var client in that static class, get clients, then we can just use entity framework here to say configDBContext.add client.toEntity. This is a helper method that is exposed by IdentityServer for entity framework.mappers. So again, this is really nice that IdentityServer 4 has these sort of add-on packages to work with entity framework out of the box. And we can be more explicit here by saying that we're adding the new clients to the clients DB sets. Then we can call save changes. This is going to go ahead and commit those inserts to our database. And I'm just going to copy this if block. And we can add some identity resources. And there's a helper method in the config class to get identity resources, and again, we can add these to the identity resources DB set, and we'll rename our iterator here just as SRES here. So for each of those resources, we add them and save changes, and then finally, let's go ahead and add API resources. So for each var API in this getAPIs method, we're going to add that API to that table as well. Oops, and this of course needs to be API resources. Okay, so this is another sort of seed data method or helper method that we have here, and what we can do is put this right at the top of configure. So we're just going to go ahead and call initializeDBContext here, and so configure is going to get called when our application starts, and so it's going to call our helper method here and new up a services scope for us. I'm going to clean this up just a little bit. And so we can just add some comments here if it helps. Using a sort of limited services scope here, we are going to use that scope to create our persisted grant database, and we can just say we're using a single DB here if it doesn't exist, and run outstanding migrations. Likewise, we can create our IdentityServer 4 configuration database. If it doesn't exist, run outstanding migrations. And then here all we're doing is generating the records corresponding to the client's identity resources and API resources that are defined in our config class. each time calling save changes on the DBContext instance to commit those changes to our database. And if we'd like to change the configuration there to create custom clients that we want set up ahead of time, then we could certainly edit this configuration file, this get clients method in particular, to change that from this sort of boilerplate code to code that is more specific to the application that we're building. And in fact, we'll look at that in future videos when we build an API and some front-end clients to work with. Okay, so all that's really left to do now is to call .NET Run, and we won't seed the database this time, but in fact we'll just run the application. So you can see in my case, I am still getting this warning about this code analyzer, but it's not affecting us really in terms of running the application right now. I should be able to install this package if it's not already properly installed in the project, and we can see this error go away, or this warning go away. In any case, you can see that IdentityServer 4, or our STS, is actually running on port 5000 of localhost. So let's go ahead and head over there and take a look. So you can see our application is now running on port 5000 of localhost, and so if we head over there and take a look, we can indeed see that we have IdentityServer 4 running. So this is really just for sort of development purposes. I mean, you don't necessarily really need a front end for IdentityServer. It runs perfectly fine in the console here, but with the templates that are provided, we can have some links here where we can see like the discovery document. And so this is a common URL that you'll see when looking at a discovery document for OpenID. We have a JSON object here, and we have some sort of key value pairs here where for various endpoints we can see the URI where that endpoint is invoked. So that's pretty interesting. And in fact, if you go to like other websites, say accounts.google.com, and hit the same suffix here on the URL, you can actually see the same public information for other websites that use this protocol. So we'll go back to our IdentityServer 4 here. We can also see our stored grants, and for this we can log in. So let's go ahead and log in using one of our test users that we seeded the database with. And so you can see that I've logged in as Alice, but that we haven't been given access to any applications. So of course this is something that we'll need to configure in the future. When we register users, we will also be able to define what applications and what resources they have access to. We can go ahead and log out, and we get some information here that we're now logged out. But perhaps even more usefully, if you take a look at what we're seeing on the console here, we can see everything that has just sort of been happening in our app. So we can see the user was just signed out. We can see where we were authenticated. We can see that we had 0 persisted grants for this particular GUID. And in fact, if we copy this and we take a look, that this actually is the user ID for Alice, who we were signed in as. So we can kind of see that in the logs as well. So one thing that I would definitely encourage you to do is, as you are building out your STS, well, a few things. For one, take a look at the docs on IdentityServer 4. They're really extremely thorough, and they have a lot of great useful information for sort of understanding exactly what we're getting into when we're building an STS. And one of the more helpful pages we have here is just called the Big Picture, that gives us a diagram of what most modern applications look like, where we have different applications, whether in the browser or some native app or from a server, hitting some web API or some web app, which again goes out and makes requests to additional web APIs. And in a worst case scenario, I would say we have different security protocols and different ways that we're protecting resources sort of at each layer of our stack, and everything still has to kind of work together. when we're moving to using an STS, you can see that each request that's made here is made using these protocols. And in fact, if we scroll down a little bit further here, you can see that it says that IdentityServer is middleware that adds the spec-compliant OpenID Connect and OAuth 2 endpoints to an arbitrary ASP .NET Core application. So this is really useful documentation. And furthermore, if you'd like to check out the protocols themselves, if you just head over to oauth.net/2, you can also read through the actual protocol itself here. This is pretty in-depth, but I'm working through reading it now myself, and I think it's always useful to go directly to the spec to see what's being implemented to get a better understanding of the problems that this protocol is solving, as well as to just get familiar with some of the vocabulary, because the API or the implementation in IdentityServer 4 is going to be pulling a lot of the nomenclature directly from the spec. Likewise, you can read more about OpenID Connect at openid.net/connect, and if we take a look directly in the specifications here at /developers/specs, again, pretty long documentation here, and seeing as this is an extension of OAuth 2, it would make sense to have some understanding of the OAuth 2 protocol before diving into OpenID Connect, I would assume. So I just wanted to make you aware that these specs are available, and I'm working through reading them myself to gain a better understanding, and it might just be a good idea in general if you are going to be implementing an STS to have some at least high-level understanding, if not more detailed understanding from the specifications that they're implementing.